Okay, thank you, Dr. Parceva, and good morning, everybody. Again, my name is Luis Hernandez. I am associated with the NRCS, the USDA Natural Resources Conservation Service Soil and Plant Science Division. We are the one who conduct soil survey all over the country. And Dr. Parceva, you just mentioned that I do international activities. Just last week, I was participating in a congress, a soil science congress in Argentina.
Oh, wow.
Yeah, it was virtual, but I was supposed to travel there, but with COVID, I mean, that changed all the plans. So I just made my presentation from here. Very interesting. The Soil and Plant Science Division, we are engaged in the international arena. I have done work all over the world, just doing soil survey, promoting cooperation, sharing our knowledge, some of the good things that we do here in the country. And universities have a role on that. You know, we rely on you guys, the university, to help us to prepare the soil scientists, the future soil scientists that later on are going to come and conduct the work that I am right now conducting in the Northeast. So anyway, I just going to go ahead and jump on this. And thank you, Anna, for that introduction. What I'm going to do is I'm going to spend about the rest of the time talking to you about the soil survey, just a big picture, overview of the soil survey program. I'm not going to go too specifics. I'm hoping that down the road you can connect with the local NRCS folks, you know, in Louisiana, and you can get more specific information about the soil, the landscapes of that neck of the woods. Let me add that I was stationed in Little Rock way back. I was the regional director for the South Central region. So I had the opportunity to travel to Louisiana. So I am very familiar with that area. So anyway, I'm gonna go ahead and keep going here. Just an outline of the information that I'm gonna share with you guys. I mean, we're gonna cover a lot of ground, all the way talking about the soil survey program, the National Cooperative Soil Survey Program, talk to a little bit about the standards, then about the land resource hierarchy, and you can see all the topics that we're going to cover all the way until the end. I'm going to touch briefly about digital soil mapping. So I'm going to go ahead and move to the next slide. Just to, so if you don't know, we've been doing this work in the US, the soil survey, since 1899. So we have roughly more than 100 years for sure, but we have about roughly about 120 years of history and experience doing this type of work all over the country and in other countries too. Again, as I said, we get engaged with our international cooperators to share information and knowledge and that type of things. So why do we, whoops, I'm sorry, I hit the key. Why do we do the soil survey in the US? Well, it's a congressional mandate. The US Congress tell us, NRCS, who is responsible for the soil survey program in the US, that we need to do an inventory of the soil resources of the country. I mean, that's the first mandate by US Congress. The other mandate is that we need to keep the inventory current. The next mandate is that we are mandated to provide interpretations and understanding to the user, the folks that use the soil survey information. And last but not least is that we are mandated to provide access and promote use of soil information. So that's why we do a soil survey in this country. Again, it's congressional mandate that we need to do this type of work, okay? How we do it? I just provide this picture, you know, that umbrella. Basically, the soil survey program provides the platform where anyone out there, doesn't matter, federal sector, state government, private sector, universities, NGOs, non-government organizations, whoever is out there that wants to join us and work with us and help us share resources. I mean, just sitting on the table with us and talk to us about the needs. I mean, all of that, the Soil Survey Program, the National Cooperative Soil Survey Program provides that platform where anyone can come to the table and work with us. Now, we have offices all over the country, all the way from Hawaii to the Caribbean area. I mean, Alaska, or the lower 48. We have offices spread out all over the country. And you may be wondering, you know, I mean, how you guys do the work with consistency. What ensure the consistency in the soil survey program is what we call National Cooperative Soil Survey Standards. You can see here, this is one of them. This is the Soil Survey Manual. This one provides the guidelines to the field offices to conduct the work, just the mechanics. Another national standard is the keys to soil taxonomy. This provide help us, you know, with the process of soil classification. And then we have the field book for describing and sampling soils. This is just another national standard that we provide to the offices to do the work. So we all do the work in a consistent manner. Doesn't matter if you are in Alaska and then you have another soil scientist doing the work in Puerto Rico, for example, you know, I mean, or Louisiana. Again, these are the standards. All of this information is available online. You can go ahead and download this information. I'm going to share with you at the end the soils webpage, so you can go ahead and dig it out. There's plenty of information. This is just some of the standards that we use. We have more, and we have all kinds of publications about soils, soil survey. So again, I'm going to provide you the webpage, so you can then go ahead and do your homework if you are interested in digging out more specific information. Let me go here and talk a little bit about a concept, and this is how we conduct the work. If you are going to do cartography, in this case, soil cartography, you need to be familiar with scales. So the land resource hierarchy, that's what that, I mean, this diagram, that's what that shows. What is the hierarchy? So again, we go out there, we study the landscape, we do landscape analysis, and I'm going to talk to you a little bit about that in a little bit later. And we assess, you know, the landscape. We select a pedum. It's a point on a specific landscape that we study and classify, and then we assign, define the range of characteristics. That is the soil series. And then that is what we use for the map unit name. And that's how we do the mapping. So again, we go to the very specific a point on the landscape. Then I also want to, whoops, I'm sorry. Another thing about this diagram is that I want that you look at all of these, they say order 2, order 3. Again, it relates to mapping scale. So order 1 soil survey is a very specific soil survey. I mean, it goes to the components level. And then you have another category, the order 2 and order 3. This is the type, the order 2 and order 3 is the soil survey that we are conducting right now as we speak. And then you can see how it goes from the point, very specific, from the point, and then goes higher in the hierarchy to the land resource region. I'm going to talk to you about the land resource region and the major land resource areas in a moment. But again, please understand that when you are doing cartography, you need to understand mapping scale. And this diagram, that is what that shows. How when we do the work, we go from a point all the way to the land resource region. I'm going to talk about all of these upper categories in a moment. There is a publication. Those of you that want to learn more about MRAs or major land resource area and land resource area, there is a good publication that is on the soil webpage, and you can see it right here on the left side of the PowerPoint slide. This publication gives you plenty of information about the land resource regions all over the country and the major land resource areas. We are in the process of updating this publication. It's going to be released, the new edition, by the end of this calendar year. But this is a publication that if you want to go a little bit deeper, you know, to study this, the land resource areas and the major land resource area, this is the publication I recommend to you. Land resource regions, or LRR, what is that? Very broad patterns of soil, climate, water resources, and land use. Currently, we have about 28 all over the country, and we use the letters to identify each of the land resource regions. And you can see the map on the left for the lower 48, you know, just to give you an example of, you know, how the distribution of the land resource regions in the country. Major land resource areas, or MRA. Again, in a nutshell, MRA is a geographic area where all the soils, the geology, the land use, climate, and other natural resources are the same. Currently, we have in the country about 278. I think that number is going to go down because we are revising. Now we have better technology. We have computers. We have more precise computer models to do computer analysis and to better define the boundaries of the MRA. So I think when we finish the revision that we are doing to the MRAs, we're going to go from 278 down to 270. And then last but not least, we use the alphanumeric symbol to identify the MRAs. And you can see on the left side of the PowerPoint slide, just an example of the distribution of the MRAs in the lower 48. I'm assuming that you guys already talked about soil formation factors. You already took a class about soil formation processes.
Yes.
I'm not going to go too deep in the woods, because that's my assumption that you guys already are familiar with all of this concept, but we need to talk briefly about it before we go deeper in our conversation. Again, the soil formation processes, you can see on this diagram that the theory is that the processes consist of additions to the soil, translocations that take place in the soil, transformations that take place in the soil, and losses that take place in the soil. But when you combine this concept with the soil formation factors, it gives us what we call the soil genesis theory. So let me go here. So again, I'm assuming that you guys are ready you are familiar with the soil formation factors. So if not, you need to let me know.
Oh, no, I know that. Yep, I know. Mm-hmm.
Okay, good deal. Okay, so the soil genesis theory. I'm going to use a diagram here just to explain this, how all of this works. So one of the soil formation factors is what? The parent material. Parent material get to a time 0. Again, let's say that, you know, you're going back to the late Pleistocene, that the glacier came south and deposited all of these glacier drift. That's the parent material in time 0. Then the other soil formation factors and the processes acted on it and created what we see today. And that is what we call the soil morphology, okay? So when you combine all of these, the processes, the soil formation processes and the soil formation factors, you can see here, you know, a brief description of the soil formation processes, the addition, the removal, the transformations, and the transfer. And that create different horizons in the soil. And you can see on the left side, this is just an example of a spodosaur. I do not know if you have spodosaurs in Louisiana. I don't think so, but there may be places that you may have them. But anyway, it creates all of these horizons that we define them based on the physical and chemical properties. So in this case here, you can see that, in ocric epipedon, an Arbic horizon, a spodic horizon. So then we use all of these horizons. We describe them with some convention that we use. And then this is what we call this information right here, all of this type of horizon, the diagnostic horizon. This is what we use for soil classification, okay? So if you think about it, if you want to know the age of a tree, you just cut the tree and then you count the rings, and that will give you a general idea of the age of the tree, what happened during the time that this tree was growing. So for soils, it's very similar. It's the same concept. So again, you have a parent material, and you have the processes and the factors acting on it and working on it and creating all of these soil layers that we use to classify the soil and to develop the cartography of the landscape. Okay. We have a soil classification system. You can see that the most basic at the bottom, at the base of the pyramid, is the soil series. Okay, so the order, this is very general, and then you can see all the different categories until we get down to the soil series. The soil series is what we use for cartography to make soil maps. Let me talk to you just briefly. We're going to go now a little bit into the landscape analysis. But before we go there, I think that this is a concept. Hopefully you already discussed this, so it's going to be a repetition. I encourage you that when you're driving throughout, Louisiana, that you look at the landscape, like this diagram is showing here. This is a landscape, and visually you cut out the landforms. And you can see here in an example of a landform, just to give you an idea. Now, that landform has a population. This is pure statistic, what you're going to do from this point on. And I'm going to explain that to you later on, when we talk about how we do the landscape analysis. But you have a population of pedons, right? This is what this is showing right here, all of these pedons. Then you are going to do landscape analysis, and you are going to select a pedon that represent that landform. And that is this pedon right here that is showing in this diagram. Okay, so then you take that pedon, you are going to describe the pedon. A very detailed description. That's the pedon that represents the populations of pedons in that landform. This pedon, you're going to describe it. You are going to take soil samples, you send it to the lab. We have a national soil lab for the soil survey in Lincoln, Nebraska. And then you are going to assign a soil series. As I showed previously, we have 22,000 plus soil series recognized in the U.S. So we are not promoting to establish many soil series. What we want that our specialists do is that as they do the work, that they look for those soil series that have been established. So if you go to a new area and you find as you are doing describing and classifying the pedon, what you want to do is to look if there is a soil series that has been established already, and then you can use that soil series in the county or where you're doing the work. Again, we are not promoting to establish too many soil series. We have already about 22,000 plus in the country. Okay, let's talk a little bit about landscape analysis. Landscapes can repeat in short distances. So if you look at this picture right here, you can see this landscape, and it just go back to what I said. You know, you are going to cut out the landform. So what I see here on this picture is that I see an area right here. I see like a creek, and then I see here what appears to be a floodplain. Okay, so I will cut out all of this area, and that's a landform. I go in there, and I run what I'm going to be talking to you, a transit. The same right here on this side slope. Again, you are going to cut out the side slope from the top of the hill. And again, you go in there and you are going to do landscape analysis. Now, again, going back to what I said, landforms repeat in short distances. So if you run a transit in let's say in that floodplain, moving you know, far away from this area, you're going to find a repetition of the same landform, the floodplain. The question is you need to go and do a specific transit and description, and the answer is no, you don't. Again, you're going to be able over time, if you conduct this type of work, to predict and use statistics to define probabilities. And again, there are going to be situations that you are going to be able, based on what you already know, what you already study, like for this particular landscape, you don't need to collect additional data. Now, we have a process that we call it quality assurance. We have two processes in soil survey: quality control and quality assurance. When you are doing the statistic, determining the map unit composition, doing the landscape analysis, that's part of the quality control. The quality assurance is the process that we use to basically make sure that the work that we do meet the National Cooperative Soil Survey standards. So it's a lot of information that I can share with you guys, but again, I'm just going to keep going for the sake of the time. So let's talk about
Just a second, Luis. Blair has a question.
Go ahead.
Hi, thank you. I just wanted to ask, so just to make sure, so whenever you're taking the ped on, you would take it one from the floodplain, and then you would take a ped on one from the, I guess you'd call that like the downslope?
The side slope.
Side slope, yeah.
Okay.
So those ped-ons would like predict, would you predict those ped-ons to be different, right? Because they have the different maybe weathering and stuff. Okay, so all right, yeah. So
you are right on track. But let me repeat this again. So again, you have the landscape. You're gonna cut out the landform. So I said, well, I see a landform here. I see the floodplain, and then I said, well, I see the side slope. Again, going back to your question, yes, I will forecast that the soil formation factors in that floodplain are going to be completely different to the soil formation factor and processes on the side slope. So what I will do, I will come and I'm going to talk to you guys a little bit about transit. But you will run a transit just to see what is the soil population, what is the diversity, or what we call a spatial variability of soils within that landscape. So you're going to run a transit. Again, you define the landform, you run a transit, and you're going to, I mean, normally we use a 10-point transit, that 10 is not a magic number. That is up to the soil scientist or the person that is doing the field work to determine what will give more confidence to represent what is out there. So you run the transit. Let's assume that you select again this floodplain. Then you do a 10-point transit. And then let's say that out of the 10 point that you went out there with an auger, you took made a description. Let's say that 8 of the 10 points, you found a soil that you're gonna call it alpha, just to give you an example. And then the other 2 points, there were other soils similar, but that do not qualify for that alpha soil, and you call that beta soil. So what you do, because alpha was the most dominant soil, then you're gonna have to select one pedon that represent that alpha, which is like the central statistic. You know, when you have a bell curve, is that one that is right in the middle, and that's the soil that you are going to associate with a soil series. Again, we do not encourage to folks out there to keep proposing new soil series. What we want folks is looking at which soil series are already established out there. We have established that we can use to characterize this particular landscape. That's the one that we're going to describe in detail. We're going to take soil samples, we're going to send it to the lab, and then on the cartography side, that alpha soil series is what we're going to use in the map unit name. So just to give you an example, that's going to be share with you a map unit name, and I am making up out of this. Okay, so that 80% alpha, then you can say that the map unit name is alpha Sitlum. I'm going to say, well, this may be a flat area, 0 to 3% slope. And I don't know, I went a little bit beyond what you asked, but that was a good question, and thank you. But hopefully I got the, I think that you are right on track. You understanding of how we, do this type of work. Talk about transecting. Okay, so again, now we are talking here about landscape analysis. So you got that landscape at the floodplain, and then as I said, you're gonna run a transit, fix length intervals. It's not going to be continuous. And again, you go and do there what I already showed with you guys that you're going to do. You're going to use a statistic, to identify the composition of the delineation. And again, as I said, this is what you're going to use this information to design the map unit. And that's what you're going to use in cartography to develop the map unit names. Again, you're going to look at a lot of things when you are running a transit. In each point, you're going to, describe what you see. You're going to describe vegetation, if that is possible. I mean, if you're familiar with the vegetation, you're going to forecast the composition when you finish the transit. You're going to describe characteristics on the surface, like rock fragment or surface fragments, or other categories like amount of outcrop, for example. And again, we use this concept of transecting the landscape, in all soil surveys, type of soil survey work that we do. Okay, so let me go here. So I'm going to ask you guys a question, and so I can take a break and engage you in the conversation. So where do transit work well? Well, let me share with you. Okay, so where you have spatial variability, that's where the transit do well. Again, you are going to use the transit. You were talking about the bottom part that has been farmed. Well, appears that it's an area that is on farm, activity. Again, you're going to run the transit, and what you want to do is to find out what is the population of pedons in that particular landform, and the transit is going to give that information to you. So again, I don't know if my question was, if I use the right wording to ask the question, but again, just always remember, when I want to do landscape analysis, I want to find out, if I want to find out what is the population of pedons out there, or what is the composition, the map, what we call the map unit composition. That's what you do. You run a transit, and I just put there an example. Again, this is not real. I just sharing with you some examples just to give you, the background information. You're gonna have to do some additional homework down the road to get more specifics about how all of these signs work. But again, we do the transecting just to find out what is the spatial variability on the landscape. Okay, let me keep going. Here's an example. You have a delineation, and then you're going to position the transect line again to trying to define what is the spatial variability within that delineation. I want to call it a landform. Okay, and then normally the transect line should go from the highest point, part of the landscape, to the lowest part. Okay, and I hopefully you understand that. Let me go back for a second and I see I can. Okay. So as you said, the bottom part, I will think that the soil population in that part of the landscape is going to be completely different to the soils that occur on the side slope. Again, I think that what you want to do is to run a transit, like in this particular landform, from the highest point, appears to me is right here somewhere where the trees are, down just to this point right here is the lowest part of that particular landform. Now, if you run the transit like across like this, whoops, do you think that is going to give you the spatial variability of that particular landform? And that is a question. Let me ask the question again. If you run a transit from here, just a line, or that goes like this, straight line, to the other side of the landform, do you think that you're going to be getting the information that you need in regards to spatial variability in that particular landform? That's a question. And yes or no, you need to tell me why. Explain why. Anyone? You guys are too timid. And come on, just give it a shot. Okay, go ahead.
I will ask you this on the exam, so you better answer and get the right answer.
No. Again, we are learning here as we go. Again, let me ask the question one more time. If you run a transit from this point, and then you go straight line to this point, the question is, if you think that running the transit just across the way that I just said, that if that is going to give you the some information about the spatial variability in that particular landform, is that a yes or no?
I would say no.
Okay, good. That's the right answer. Okay, now why you think it's a no?
If you go like across, like you said, that might be at the same elevation, and so it's kind of biased. And maybe it's like more uniform too. So like you'll probably get the same, types of soil, like because it's the same elevation. So you won't have any diversity, or as much diversity maybe.
That is exactly true. That is why, the soil formation factors. Again, always keep this in mind. Soil formation factors, soil processes. Those are the ones that are going to define the kind of soil type that you're going to find in a specific position on the landscape. If you learn to recognize of the soil formation factors and the soil formation processes, what are the most dominant in a particular area. Doesn't matter if you are in Australia or you are in Russia, doesn't matter where you are. If you can develop that skill, that you go to an area that you never been there, but you are asked to do a soil survey, I think that the very first step, I think for you, is to define what are the most dominant soil formation factors and processes in this particular area, because that is what is going, to define the soil types that are going to occur in that particular area. So just as you said, if you run a transit here, I think that you're going to be in the same landscape position. You're going to be right there. I think that that's not going to give you the spatial variability, because the soil formation factor and processes along that transit are going to be the same. However, when you go from the highest point to the border point, you're going to get the spatial variability. Because just to give you an example, how water moves, just to give you an example, the landscape. The water goes right from the highest point to the lowest point. That's how water moves. And when we talk about water movement in soil, I mean, it's another class that, or maybe different classes that we will have to line up just to discuss how water affects the soil formation and all of that. But that is the right answer. That's exactly why. Let me go back. Excuse me, let me see. How much time do I have, Dr. Parsiva?
Another 10 minutes.
What was that?
Another 10 minutes.
Okay, got it. Let's see, we are getting there. We talk about this. We talk about this. We talk about this. Okay. Here's another question for you guys, and we have 10 more minutes, so we gotta move a little bit fast. But another question for you guys: what kind of situations call for other methodology? We're talking about transecting. That works well, when you have defined landforms. But do you think that the transecting methodology is going to work everywhere? Yes or no, and why?
This type of transect research, would it be feasible in a wetland situation?
Yeah, wetland situations. Yeah, well, I would say that on borderlands, it applied to that. I would say yes. Let me keep going, because we don't have too much time left, and I want to give you guys a few minutes to ask me questions about anything that you want to ask me in regards to what we do. Okay, so again, as you said, here's an example, on this picture. You can see like a water body. It's a borderland, and there are situations out there that when you run a transit, that's not going to give you the information in regards to spatial variability. There are going to be landscapes that are very complex out there, but that the spatial variability is a random, and a transit is not going to give you, the information that you're looking for. So there are other methodologies like you can use grids, and you can use stratify random. So these are just, I want to make sure that you guys understand that transit is not going to work everywhere. There are going to be situations that the landscape is so complex that you're going to have to use other methodology to get information that you need to know in regards to spatial variability. Let me keep going. There are other information that you can use as you do landscape analysis, aerial photography, digital elevation models, topo maps, geology maps, vegetation maps. many other resources that are available out there, including even soil survey information where we have done the work already. Kind of map units, again, I'm not going to go too deep in regards to the kind of map units. I just want that you know that we use 4 types of map units: the consociations, the complexes and associations, and then the undifferentiated groups. And you can see the definition. The consociation, you have a soil that you know, an area that is dominated by one component, like the example I shared with you on that landscape picture, 80% of alpha versus 20% beta. That would be a consociation because it's 80% and is the most dominant soil. And then you can see the complexes and association. For the complexes, 2 or more dissimilar components that occur on the landscape, and they just cannot be separated at the scale that you are mapping. Anyway, I just want that you become familiar with this type of concept. Most of the time, what we use, we use all of these 4 kind of map units in the soil survey. That's why we have them. But at least in my experience, the consociations, the complexes, and the associations are the ones that I have used most of the time. Here and there, I have used the undifferentiated group, but it's something that we do not encourage, because what we want to give the user is plenty of information that they can use to make the decision that they need to make in regards to the land use. So anyway, I want to leave it there in regards to map units. I want to talk a little bit about urban soils. I'm going to circle all of this. What is those things that I just circled on that picture? Does anyone know?
Seems
just
to
looking
be
at it.
Brick.
Say that again.
Is it like shards of brick and different?
Yeah, right, exactly. Yeah, those are human artifacts. So right now we are conducting urban soil survey in different parts of the country. Right now we have soil survey in the city of Denver as we speak. But urban soils are, soil that has been impacted by human activity. Like in this particular example, you can see, in this soil profile, pieces of bricks, plastics. There are other things there that I can see. But again, we in the past, we focused the soil survey on rural areas. Now we are moving into urban areas and coastal zones too. So I just briefly about urban soils. Where are the urban soil? Where do you find them? I'm going to show you this picture of NASA that shows the lights during the night across the globe. And this is where this is what we have cities and we have humans. This is what more probably, humans impacted the soil by moving, by cutting, by filling. Again, I just want to give you an example where this type of soils occur. The soil survey manual, as I said, is one of the national standards. You can go, there is a chapter just for, to guide us, soil scientists to characterize the human soil that have been impacted by humans. Just a few publications that we have done in New York City, the Sarah Tourette. All of this is on the internet, guys, okay? Gateway, the Reconnaissance Soil Survey in New York City. I'm sorry, you can see at the bottom, Chicago, Detroit, Los Angeles. We have done work, Washington, D.C., Baltimore. As I said, we're doing this type of work in Denver. All information, we have the cartography completed, is available on the website survey. You go to the website survey, you're going to be able to just make maps. It's an interactive tool. You need a computer, access to the internet, and you can go to the website survey. You can develop interpretation maps for your farm. We are now using the intelligent telephone or iPhones. We have there is an app that you can go and dig it out from the App Store, and it's free. And the beauty of that is that whatever you have the cartography, you can stand with your iPhone, and it's going to give you, as you can see on that picture, the profile and abortions information. This app, the Soil Web, was developed in cooperation with UC Davis. Now we're talking about digital soil mapping. This is the future. This is for you guys, because again, we are beginning to do this work, but it is plenty of work that is going to be left for the next generation of soil scientists. What we're doing is, with digital soil mapping, is feeding a computer model with information, all the information that is available in regard to soils, climate, digital elevation model, you name it. And then this computer model cook all of this information, and it just forecasts what is going to be the soil on the landscape. Then the soil scientists go and check out, what the computer is saying. They go to the field and check it out. This is the future. This is what we're doing right now. And as you can see in this particular map, you can see the level of detail that the digital soil mapping, the raster soil survey, is going to provide to us moving forward. And that's going to open the doors to do what we call dynamic soil survey, where we're going to be able to forecast a particular property on a particular point, a specific time. I mean, this is going to be great. What we're going to be able to do, after we complete the raster soil survey, and then we get into this dynamic soil survey. This information is going to be great to do landscape analysis. In this particular case, example, you see the map is a 1-inch rain, and you can see what happened over time in regards to how the soil moisture of the soil, runoff. I mean, this is going to be great moving forward, in the future. And this is going to be for the new generation, like some of you guys, okay? Again, I'm getting close to my presentation. I just want to say that it doesn't matter what you do, but you need to keep in mind the user, the customer. I'm going to show you this picture. In this picture, you can see that someone is building a house, but you can see that maybe the cost of building the house were higher, because if the person did not check out the soil survey to find out that there was bedrock, then you can see maybe the building the house, it costs more money, because they have to take out all of that bedrock to place that house foundation, and again, always customer, find out what the customer needs. And then after that conversation, then is that you're going to design the soil survey, what you're going to do. Okay. Are you going to say thank you? I'm sorry I went